Welcome back to my channel. In this video we will understand OSI model. OSI stands for Open Systems Interconnection. It has been developed by ISO, International Organization for Standardization, in the year 1984. It is a 7-layer architecture with each layer having specific functionality to perform. All these 7 layers work collaboratively to transmit the data from one person to another across the globe. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. What is physical layer? The physical layer is the bottommost layer in the Open System Interconnection (OSI) model, which is a physical and electrical representation of the system. It consists of various network components such as power plugs, connectors, receivers, cable types, etc. The physical layer sends data bits from one device, S, like a computer, to another device, S. The physical layer defines the types of encoding, that is how the 0S and 1S are encoded in a signal. The physical layer is responsible for the communication of the unstructured raw data streams over a physical medium. Functions performed by physical layer. The following are some important and basic functions that are performed by the physical layer of the OSI model. 1. The physical layer maintains the data rate, how many bits a sender can send per second. 2. It performs the synchronization of bits. 3. It helps in transmission medium decisions, direction of data transfer. 4. It helps in physical topology, mesh, star, bus, ring, decisions, topology through which we can connect the devices with each other. 5. It helps in providing physical medium and interface decisions. 6. It provides 2 types of configuration: point-point configuration and multi-point configuration. 7. It provides an interface between devices, like PCs or computers, and transmission medium. 8. It has a protocol data unit in bits. 9. Hubs, Ethernet, etc. devices used in this layer. 10. This layer comes under the category of hardware layers, since the hardware layer is responsible for all the physical connection establishment and processing too. 11. It provides an important aspect called modulation, which is the process of converting the data into radio waves by adding the information to an electrical or optical nerve signal. 12. It also provides a switching mechanism wherein data packets can be forwarded from one port, sender port, to the leading destination port. Physical topologies. Physical topology or network topology is the geographical representation of linking devices. Following are the 4 types of physical topology. 1. Mesh topology. In a mesh topology, each and every device should have a dedicated point-to-point connection with each and every other device in the network. Here there is more security of data because there is a dedicated point-to-point connection between 2 devices. Mesh topology is difficult to install because it is more complex. 2. Star topology. In star topology, the device should have a dedicated point-to-point connection with a central controller or hub. Star topology is easy to install and reconnect as compared to mesh topology. Star topology doesn't have fault tolerance technique. 3. Bus topology. In a bus topology, multiple devices are connected through a single cable that is known as backbone cable with the help of tap and drop lines. It is less costly as compared to mesh topology and star topology. Reconnection and reinstallation are difficult. 4. Ring topology. In a ring topology, each device is connected with repeaters in a circle-like ring, that's why it is called ring topology. In ring topology, a device can send the data only when it has a token. Without a token no device can send the data, and a token is placed by monitor in ring topology. Line configuration. Point-to-point configuration. In point-to-point configuration, there is a line, link, that is fully dedicated to carrying the data between 2 devices. Multi-point configuration. In a multi-point configuration, there is a line, link, through which multiple devices are connected. Modes of transmission medium. 1. Simplex mode. In this mode, out of 2 devices, only one device can transmit the data, and the other device can only receive the data. Example: input from keyboards, monitors, TV broadcasting, radio broadcasting, etc. 2. Half-duplex mode. In this mode, out of two devices, both devices can send and receive the data but only one at a time, not simultaneously. Examples: walkie-talkie, railway track, etc. 3. Full duplex mode. In this mode, both devices can send and receive the data simultaneously. Examples: telephone systems, chatting applications, etc. Physical layer protocols. Examples. Typically, a combination of hardware and software programming makes up the physical layer. It consists of several protocols that control data transmissions on a network. The following are some examples of Layer 1 protocols. 1. Ethernet with 1000 BASET. 2. Ethernet with 1000 base SX. 3. Ethernet at 100 BASET. 4. Synchronous digital hierarchy/optical synchronization. 5. Physical layer variations in 802.11. 6. Bluetooth. 7. Networking for controllers. 8. US serial bus. What is data link layer? The data link layer is the second layer from the bottom in the OSI, Open System Interconnection, network architecture model. It is responsible for the node-to-node delivery of data. Its major role is to ensure error-free transmission of information. DLL is also responsible to encode, decode, and organize the outgoing and incoming data. This is considered the most complex layer of the OSI model as it hides all the underlying complexities of the hardware from the other above layers. Sublayers of data link layer. The data link layer is further divided into two sublayers, which are as follows. Logical link control, LLC. This sublayer of the data link layer deals with multiplexing, the flow of data among applications and other services, and LLC is responsible for providing error messages and acknowledgements as well. Media access control, MAC. MAC sublayer manages the device's interaction, responsible for addressing frames, and also controls physical media access. The data link layer receives the information in the form of packets from the network layer. It divides packets into frames and sends those frames bit by bit to the underlying physical layer. 1. Framing. The packet received from the network layer is known as a frame in the data link layer. At the sender's side, DLL receives packets from the network layer and divides them into small frames, then sends each frame bit by bit to the physical layer. It also attaches some special bits, for error control and addressing, at the header and end of the frame. At the receiver's end, DLL takes bits from the physical layer, organizes them into the frame, and sends them to the network layer. 2. Addressing. The data link layer encapsulates the source and destination's MAC address/physical address in the header of each frame to ensure node-to-node delivery. MAC address is the unique hardware address that is assigned to the device while manufacturing. 3. Error control. Data can get corrupted due to various reasons like noise, attenuation, etc. So, it is the responsibility of the data link layer to detect the error in the transmitted data and correct it using error detection and correction techniques respectively. DLL adds error detection bits into the frame's header, so that receiver can check received data is correct or not. 4. Flow control. If the receiver's receiving speed is lower than the sender's sending speed, then this can lead to an overflow in the receiver's buffer and some frames may get lost. So, it's the responsibility of DLL to synchronize the sender's and receiver's speeds and establish flow control between them. 5. Access control. When multiple devices share the same communication channel, there is a high probability of collision, so it's the responsibility of DLL to check which device has control over the channel, and CSMA/CD and CSMA/CA can be used to avoid collisions and loss of frames in the channel. Protocols in data link layer. There are various protocols in the data link layer, which are as follows. Synchronous Data Link Protocol, SDLC. High-Level Data Link Protocol, HDLC. Serial Line Interface Protocol, SLIP. Point-to-Point Protocol, PPP. Link Access Procedure, LAP. Link Control Protocol, LCP. Network Control Protocol, NCP. What is network layer? The network layer is the third layer in the OSI model of computer networks. Its main function is to transfer network packets from the source to the destination. It is involved both the source host and the destination host. At the source, it accepts a packet from the transport layer, encapsulates it in a datagram, and then delivers the packet to the data link layer so that it can further be sent to the receiver. At the destination, the datagram is decapsulated, and the packet is extracted and delivered to the corresponding transport layer. Features of network layer. 1. The main responsibility of the network layer is to carry the data packets from the source to the destination without changing or using them. 2. If the packets are too large for delivery, they are fragmented, i.e., broken down into smaller packets. 3. It decides the route to be taken by the packets to travel from the source to the destination among the multiple routes available in a network, also called routing. 4. The source and destination addresses are added to the data packets inside the network layer. Services offered by network layer. The services which are offered by the network layer protocol are as follows. 1. Packetizing. 2. Routing. 3. Forwarding. 1. Packetizing. The process of encapsulating the data received from the upper layers of the network, also called payload, in a network layer packet at the source and decapsulating the payload from the network layer packet at the destination is known as packetizing. The source host adds a header that contains the source and destination address and some other relevant information required by the network layer protocol to the payload received from the upper layer protocol and delivers the packet to the data link layer. The destination host receives the network layer packet from its data link layer, decapsulates the packet, and delivers the payload to the corresponding upper layer protocol. The routers in the path are not allowed to change either the source or the destination address. The routers in the path are not allowed to decapsulate the packets they receive unless they need to be fragmented. 2. Routing. Routing is the process of moving data from one device to another device. These are two other services offered by the network layer. In a network, there are a number of routes available from the source to the destination. The network layer specifies some strategies which find out the best possible route. This process is referred to as routing. There are a number of routing protocols that are used in this process, and they should be run to help the routers coordinate with each other and help in establishing communication throughout the network. 3. Forwarding. Forwarding is simply defined as the action applied by each router when a packet arrives at one of its interfaces. When a router receives a packet from one of its attached networks, it needs to forward the packet to another attached network, unicast routing, or to some attached networks, in the case of multicast routing. Routers are used on the network for forwarding a packet from the local network to the remote network. So, the process of routing involves packet forwarding from an entry interface out to an exit interface. Difference between routing and forwarding. Routing. Routing is the process of moving data from one device to another device. Operates on the network layer. Work is based on forwarding table. Works on protocols like Routing Information Protocol, RIP, for routing. Forwarding. Forwarding is simply defined as the action applied by each router when a packet arrives at one of its interfaces. Operates on the network layer. Checks the forwarding table and work according to that. Works on protocols like UDP encapsulating security payloads. Other services expected from network layer. 1. Error control. 2. Flow control. 3. Congestion control. Error control. Although it can be implemented in the network layer, it is usually not preferred because the data packet in a network layer may be fragmented at each router, which makes error checking inefficient in the network layer. Flow control. It regulates the amount of data a source can send without overloading the receiver. If the source produces data at a very faster rate than the receiver can consume it, the receiver will be overloaded with data. To control the flow of data, the receiver should send feedback to the sender to inform the latter that it is overloaded with data. There is a lack of flow control in the design of the network layer. It does not directly provide any flow control. The datagrams are sent by the sender when they are ready, without any attention to the readiness of the receiver. Congestion control. Congestion occurs when the number of datagrams sent by the source is beyond the capacity of the network or routers. This is another issue in the network layer protocol. If congestion continues, sometimes a situation may arrive where the system collapses and no datagrams are delivered. Although congestion control is indirectly implemented in the network layer, still there is a lack of congestion control in the network layer. Advantages of network layer services. Packetization service in the network layer provides ease of transportation of the data packets. Packetization also eliminates single points of failure in data communication systems. Routers present in the network layer reduce network traffic by creating collision and broadcast domains. With the help of forwarding, data packets are transferred from one place to another in the network. Disadvantages of network layer services. There is a lack of flow control in the design of the network layer. Congestion occurs sometimes due to the presence of too many datagrams in a network that is beyond the capacity of the network or the routers. Due to this, some routers may drop some of the datagrams, and some important pieces of information may be lost. Although indirect error control is present in the network layer, there is a lack of proper error control mechanisms as due to the presence of fragmented data packets. Error control becomes difficult to implement. What is transport layer? The transport layer is the second layer in the TCP/IP model and the fourth layer in the OSI model. It is an end-to-end layer used to deliver messages to a host. It is termed an end-to-end layer because it provides a point-to-point connection rather than hop-to-hop, between the source host and destination host to deliver the services reliably. The unit of data encapsulation in the transport layer is a segment. Working of transport layer. The transport layer takes services from the application layer and provides services to the network layer. At the sender's side, the transport layer receives data, message, from the application layer and then performs segmentation, divides the actual message into segments, adds the source and destination's port numbers into the header of the segment, and transfers the message to the network layer. At the receiver's side, the transport layer receives data from the network layer, reassembles the segmented data, reads its header, identifies the port number, and forwards the message to the appropriate port in the application layer. Responsibilities of a transport layer. The process-to-process delivery. End-to-end connection between hosts. Multiplexing and demultiplexing. Congestion control. Data integrity and error correction. Flow control. The process-to-process delivery. While data link layer requires the MAC address, 48 bits address contained inside the network interface card of every host machine, of source destination hosts to correctly deliver a frame, and the network layer requires the IP address for appropriate routing of packets. In a similar way, transport layer requires a port number to correctly deliver the segments of data to the correct process amongst the multiple processes running on a particular host. A port number is a 16-bit address used to identify any client-server program uniquely. End-to-end connection between hosts. The transport layer is also responsible for creating the end-to-end connection between hosts, for which it mainly uses TCP and UDP. TCP is a secure, connection-oriented protocol that uses a handshake protocol to establish a robust connection between two end hosts. TCP ensures the reliable delivery of messages and is used in various applications. UDP, on the other hand, is a stateless and unreliable protocol that ensures best effort delivery. It is suitable for applications that have little concern with flow or error control and requires sending the bulk of data like video conferencing. It is often used in multicasting protocols. Multiplexing and demultiplexing. Multiplexing, many to one, is when data is acquired from several processes from the sender and merged into one packet along with headers and sent as a single packet. Multiplexing allows the simultaneous use of different processes over a network that is running on a host. The processes are differentiated by their port numbers. Similarly, demultiplexing, one-to-many, is required at the receiver side when the message is distributed into different processes. Transport receives the segments of data from the network layer, distributes and delivers it to the appropriate process running on the receiver's machine. Congestion control. Congestion is a situation in which too many sources over a network attempt to send data and the router buffers start overflowing, due to which loss of packets occurs. As a result, the retransmission of packets from the sources increases the congestion further. In this situation, the transport layer provides congestion control in different ways. It uses open-loop congestion control to prevent congestion and closed-loop congestion control to remove the congestion in a network once it occurred. TCP provides AIMD, additive increases, multiplicative decrease and leaky bucket technique for congestion control. Data integrity and error correction. The transport layer checks for errors in the messages coming from the application layer by using error detection codes, and computing checksums. It checks whether the received data is not corrupted and uses the ACK and NACK services to inform the sender if the data has arrived or not, and checks for the integrity of data. Flow control. The transport layer provides a flow control mechanism between the adjacent layers of the TCP/IP model. TCP also prevents data loss due to a fast sender and slow receiver by imposing some flow control techniques. It uses the method of sliding window protocol, which is accomplished by the receiver by sending a window back to the sender informing the size of data it can receive. Protocols of transport layer. Transmission Control Protocol, TCP. User Datagram Protocol, UDP. Stream Control Transmission Protocol, SCTP. Datagram Congestion Control Protocol, DCCP. AppleTalk Transaction Protocol, ADP. Fiber Channel Protocol, FCP. Reliable Data Protocol, RDP. Reliable User Data Protocol, RUDP. Structured Stream Transport, SST. Sequenced Packet Exchange, SPX. What is Session Layer? The session layer is the fifth layer in the Open System Interconnection, OSI, model. This layer allows users on different machines to establish active communications sessions between them. It is responsible for establishing, maintaining, synchronizing, terminating sessions between end-user applications. In session layer, streams of data are received and further marked, which is then resynchronized properly, so that the ends of the messages are not cut initially and further data loss is avoided. This layer basically establishes a connection between the session entities. This layer handles and manipulates data which it receives from the session layer as well as from the presentation layer. Application layer. Presentation layer. Present layer equals session layer. Transport layer. Network layer. Data layer. Physical layer. Working of session layer. Working of session layer. Session layer, which is the fifth layer in the OSI model, uses the services provided by the transport layer, enables applications to establish and maintain sessions and to synchronize the sessions. Now, in order to establish a session connection, several things should be followed. First thing is we should map the session address to the shipping address. The second thing is that we need to select the required transport quality of service, also referred as QoS, parameters. Next thing is we need to take care of the negotiations which should happen between session parameters. Then we further need to transmit limited transparent user data. Then at last, we need to monitor data transfer phase properly. The ability to send larger amount of data files is extremely important and a necessary thing too. Functions of session layer. The session layer, being the fifth layer in the OSI model, performs several different as well as important functions which are needed for establishing as well as maintaining a safe and secure connection. Data from presentation layer, session layer, data from transport layer. Following are some of the functions which are performed by session layer. Session layer works as a dialog controller through which it allows systems to communicate in either half-duplex mode or full duplex mode of communication. This layer is also responsible for token management, through which it prevents two users to simultaneously access or attempting the same critical operation. This layer allows synchronization by allowing the process of adding checkpoints, which are considered as synchronization points to the streams of data. This layer is also responsible for session checkpointing and recovery. This layer basically provides a mechanism of opening, closing, and managing a session between the end-user application processes. The services offered by session layer are generally implemented in application environments using remote procedure calls, RPCs. The session layer is also responsible for synchronizing information from different sources. This layer also controls single or multiple connections for each end-user application and directly communicates with both presentation and transport layers. Session layer creates procedures for checkpointing followed by adjournment, restart and termination. Session layer uses checkpoints to enable communication sessions which are to be resumed from that particular checkpoint at which communication failure has occurred. The session layer is responsible for fetching or receiving data information from its previous layer, transport layer, and further sends data to the layer after it, presentation layer. Session layer protocols. Session layer uses some protocols which are required for safe, secure, and accurate communication which exists between two end-user applications. Following are some of the protocols provided or used by the session layer. AppleTalk Data Stream Protocol, ADSP. ADSP is that type of protocol which was developed by Apple Incorporated, and it includes a number of features that allow local area networks to be connected with no prior setup. This protocol was released in 1985. This protocol rigorously followed the OSI model of protocol layering. ADSP itself has two protocols named, AppleTalk Address Resolution Protocol, AARP, and Name Binding Protocol, NBP, both aimed at making system self-configuring. Real-Time Transport Control Protocol, RTCP. RTCP is a protocol which provides out-of-band statistics and control information for an RTP, Real-Time Transport Protocol, session. RTCP's primary function is to provide feedback on the quality of service, QoS, in media distribution by periodically sending statistical information such as transmitted octet and packet counts or packet loss to the participants in the streaming multimedia session. Point-to-point tunneling protocol, PPTP. PPTP is a protocol which provides a method for implementing virtual private networks. PPTP uses a TCP control channel and a generic routing encapsulation tunnel to encapsulate PPP, point-to-point protocol, packets. This protocol provides security levels and remote access levels comparable with typical VPN, virtual private network, products. Password Authentication Protocol, PAP. Password Authentication Protocol is a password-based authentication protocol used by Point-to-Point Protocol, PPP, to validate users. Almost all network operating systems, remote servers support PAP. PAP authentication is done at the time of the initial link establishment and verifies the identity of the client using a two-way handshake. Client sends data and server in return sends authentication acknowledgement, after the data sent by client is verified completely. Remote Procedure Call Protocol, RPCP. Remote Procedure Call Protocol, RPCP, is a protocol that is used when a computer program causes a procedure, or a subroutine, to execute in a different address space without the programmer explicitly coding the details for the remote interaction. This is basically the form of client-server interaction, typically implemented via a request-response message passing system. Sockets Direct Protocol, SDP. Sockets Direct Protocol, SDP, is a protocol that supports streams of sockets over Remote Direct Memory Access, RDMA, network fabrics. The purpose of SDP is to provide an RDMA-accelerated alternative to the TCP protocol. The primary goal is to perform one particular thing in such a manner which is transparent to the application. What is Presentation Layer? Presentation Layer is the sixth layer in the Open System Interconnection, OSI, model. This layer is also known as Translation Layer, as this layer serves as a data translator for the network. The data which this layer receives from the application layer is extracted and manipulated here as per the required format to transmit over the network. The main responsibility of this layer is to provide or define the data format and encryption. The presentation layer is also called a syntax layer since it is responsible for maintaining the proper syntax of the data which it either receives or transmits to other layers. Application layer. Present layer equals presentation layer. Session layer. Transport layer. Network layer. Data layer. Physical layer. Functions of presentation layer. Data from application layer, presentation layer, data from session layer. The presentation layer, being the sixth layer in the OSI model, performs several types of functions, which are described below. Presentation layer format and encrypts data to be sent across the network. This layer takes care that the data is sent in such a way that the receiver will understand the information, data, and will be able to use the data efficiently and effectively. This layer manages the abstract data structures and allows high-level data structures, example banking records, which are to be defined or exchanged. This layer carries out the encryption at the transmitter and decryption at the receiver. This layer carries out data compression to reduce the bandwidth of the data to be transmitted. The primary goal of data compression is to reduce the number of bits which is to be transmitted. This layer is responsible for interoperability, ability of computers to exchange and make use of information between encoding methods as different computers use different encoding methods. This layer basically deals with the presentation part of the data. Presentation layer carries out the data compression, number of bits reduction while transmission, which in return improves the data throughput. This layer also deals with the issues of string representation. The presentation layer is also responsible for integrating all the formats into a standardized format for efficient and effective communication. This layer encodes the message from the user-dependent format to the common format and vice versa for communication between dissimilar systems. This layer deals with the syntax and semantics of the messages. This layer also ensures that the messages which are to be presented to the upper as well as the lower layer should be standardized as well as in an accurate format too. Presentation layer is also responsible for translation, formatting, and delivery of information for processing or display. This layer also performs serialization, process of translating a data structure or an object into a format that can be stored or transmitted easily. Features of presentation layer in the OSI model. Presentation layer, being the sixth layer in the OSI model, plays a vital role while communication is taking place between two devices in a network. List of features which are provided by the presentation layer are: presentation layer could apply certain sophisticated compression techniques, so fewer bytes of data are required to represent the information when it is sent over the network. If two or more devices are communicating over an encrypted connection, then this presentation layer is responsible for adding encryption on the sender's end as well as the decoding the encryption on the receiver's end so that it can represent the application layer with unencrypted, readable data. This layer formats and encrypts data to be sent over a network, providing freedom from compatibility problems. This presentation layer also negotiates the transfer syntax. This presentation layer is also responsible for compressing data it receives from the application layer before delivering it to the session layer, which is the fifth layer in the OSI model, and thus improves the speed as well as the efficiency of communication by minimizing the amount of the data to be transferred. Working of presentation layer in the OSI model. Presentation layer in the OSI model, as a translator, converts the data sent by the application layer of the transmitting node into an acceptable and compatible data format based on the applicable network protocol and architecture. Upon arrival at the receiving computer, the presentation layer translates data into an acceptable format usable by the application layer. Basically, in other words, this layer takes care of any issues occurring when transmitted data must be viewed in a format different from the original format. Being the functional part of the OSI mode, the presentation layer performs a large number of, data conversion algorithms and character translation functions. Mainly, this layer is responsible for managing two network characteristics: protocol, set of rules, and architecture. Presentation layer protocols. Presentation layer being the sixth layer, but the most important layer in the OSI model, performs several types of functionalities, which makes sure that data which is being transferred or received should be accurate or clear to all the devices which are there in a closed network. Presentation layer, for performing translations or other specified functions, needs to use certain protocols which are defined below. Apple Filing Protocol, AFP. Apple Filing Protocol is the proprietary network protocol, communications protocol, that offers services to Mac OS or the classic Mac OS. This is basically the network file control protocol specifically designed for Mac-based platforms. Lightweight Presentation Protocol, LPP. Lightweight Presentation Protocol is that protocol which is used to provide ISO presentation services on the top of TCP/IP based protocol stacks. Network Core Protocol, NCP. Network Core Protocol is the network protocol which is used to access file, print, directory, clock synchronization, messaging, remote command execution and other network service functions. Network Data Representation, NDR. Network data representation is basically the implementation of the presentation layer in the OSI model, which provides or defines various primitive data types, constructed data types and also several types of data representations. External Data Representation, XDR. External Data Representation, XDR, is the standard for the description and encoding of data. It is useful for transferring data between computer architectures and has been used to communicate data between very diverse machines. Converting from local representation to XDR is called encoding, whereas converting XDR into local representation is called decoding. Secure Socket Layer, SSL. The Secure Socket Layer protocol provides security to the data that is being transferred between the web browser and the server. SSL encrypts the link between a web server and a browser, which ensures that all data passed between them remains private and free from attacks. What is application layer? The application layer is topmost layer in the Open System Interconnection, OSI, model. This layer provides several ways for manipulating the data, information, which actually enables any type of user to access network with ease. This layer also makes a request to its bottom layer, which is presentation layer, for receiving various types of information from it. The application layer interface directly interacts with application and provides common web application services. This layer is basically highest level of open system, which provides services directly for application process. Present layer equals application layer. Presentation layer. Session layer. Transport layer. Network layer. Data layer. Physical layer. Functions of application layer. The application layer, as discussed above, being topmost layer in OSI model, performs several kinds of functions which are requirement in any kind of application or communication process. Following are list of functions which are performed by application layer of OSI model. Data from user. Application layer. Data from presentation layer. Application layer provides a facility by which users can forward several emails, and it also provides a storage facility. This layer allows users to access, retrieve, and manage files in a remote computer. It allows users to log on as a remote host. This layer provides access to global information about various services. This layer provides services which include email, transferring files, distributing results to the user, directory services, network resources, and so on. It provides protocols that allow software to send and receive information and present meaningful data to users. It handles issues such as network transparency, resource allocation, and so on. This layer serves as a window for users and application processes to access network services. Application layer is basically not a function, but it performs application layer functions. The application layer is actually an abstraction layer that specifies the shared protocols and interface methods used by hosts in a communication network. Application layer helps us to identify communication partners, and synchronizing communication. This layer allows users to interact with other software applications. In this layer, data is in visual form, which makes users truly understand data rather than remembering or visualize the data in the binary format, 0s or 1s. This application layer basically interacts with operating system, OS, and thus further preserves the data in a suitable manner. This layer also receives and preserves data from its previous layer, which is presentation layer, which carries in itself the syntax and semantics of the information transmitted. The protocols which are used in this application layer depend upon what information users wish to send or receive. This application layer, in general, performs host initialization followed by remote login to hosts. Working of application layer in the OSI model. In the OSI model, this application layer is narrower in scope. The application layer in the OSI model generally acts only like the interface which is responsible for communicating with host-based and user-facing applications. This is in contrast with TCP/IP protocol, wherein the layers below the application layer, which is session layer and presentation layer, are clubbed together and form a simple single layer which is responsible for performing the functions, which includes controlling the dialogues between computers, establishing as well as maintaining as well as ending a particular session, providing data compression and data encryption and so on. At first, client sends a command to server, and when server receives that command, it allocates port number to client. Thereafter, the client sends an initiation connection request to server, and when server receives request, it gives acknowledgement, ACK, to client through client has successfully established a connection with the server end. Therefore, now client has access to server through which it may either ask server to send any types of files or other documents, or it may upload some files or documents on server itself. Features provided by application layer protocols. To ensure smooth communication, application layer protocols are implemented the same on source host and destination host. The following are some of the features which are provided by application layer protocols. The application layer protocol defines process for both parties which are involved in communication. These protocols define the type of message being sent or received from any side, either source host or destination host. These protocols also define basic syntax of the message being forwarded or retrieved. These protocols define the way to send a message and the expected response. These protocols also define interaction with the next level. Application layer protocols. The application layer provides several protocols which allow any software to easily send and receive information and present meaningful data to its users. The following are some of the protocols which are provided by the application layer. Telnet. Telnet stands for Telecommunications Network. This protocol is used for managing files over the Internet. It allows the Telnet clients to access the resources of Telnet server. Telnet uses port number 23. DNS. DNS stands for Domain Name System. The DNS service translates the domain name, selected by user, into the corresponding IP address. For example, if you choose the domain name as www.abcd.com, then DNS must translate it as 192.36.20.8, random IP address written just for understanding purposes. DNS protocol uses the port number 53. DHCP. DHCP stands for Dynamic Host Configuration Protocol. It provides IP addresses to hosts. Whenever a host tries to register for an IP address with the DHCP server provides lots of information to the corresponding host. DHCP uses port numbers 67 and 68. FTP. FTP stands for File Transfer Protocol. This protocol helps to transfer different files from one device to another. FTP promotes sharing of files via remote computer devices with reliable, efficient data transfer. FTP uses port number 20 for data access and port number 21 for data control. SMTP. SMTP stands for Simple Mail Transfer Protocol. It is used to transfer electronic mail from one user to another user. SMTP is used by end users to send emails with ease. SMTP uses port numbers 25 and 587. HTTP. HTTP stands for Hypertext Transfer Protocol. It is the foundation of the World Wide Web, www. HTTP works on the client-server model. This protocol is used for transmitting hypermedia documents like HTML. This protocol was designed particularly for the communications between the web browsers and web servers, but this protocol can also be used for several other purposes. HTTP is a stateless protocol, network protocol in which a client sends requests to server and server responses back as per the given state, which means the server is not responsible for maintaining the previous client's requests. HTTP uses port number 80. NFS. NFS stands for Network File System. This protocol allows remote hosts to mount files over a network and interact with those file systems as though they are mounted locally. NFS uses the port number 2049. SNMP. SNMP stands for Simple Network Management Protocol. This protocol gathers data by polling the devices from the network to the management station at fixed or random intervals, requiring them to disclose certain information. SNMP uses port numbers 161, TCP, and 162, UDP. Thanks for watching. Don't forget to like, comment and share.